Hello and welcome back. So far we have understood the relationship between two categorical variables with a bar chart. Visually we are trying to understand whether the women in the organization are given more importance or not by looking at how many managerial people are there in the women category. Okay? Let us try to understand the relationship between the categorical variables now. Now previously what we did was, with bar chart we did some data analysis. Now we are doing hypothesis testing to understand the dependency between gender and designation. Gender and designation are categorical columns, so to understand the dependency or relationship between these two, we need to do chi-square test for independence. Whenever we say the hypothesis testing, there will be a null hypothesis and there will be an alternate hypothesis. The null hypothesis here is gender and designation are independent. The alternate hypothesis is gender and designation are dependent. So here, whenever we do a hypothesis testing, we'll get a p-value. If the p-value is less than 0.05, we need to reject the null hypothesis, or we will reject the null hypothesis. If it is more than 0.05, we say we accept the null hypothesis. 0.05 is the 5% significance level. Generally, we take 5% significance level. So let us try to do this experiment on this data, right? The gender and designation. So we have taken null hypothesis and alternate hypothesis here. To do a chi-square test, we need to pass the contingency table. So whatever we are seeing here is called as contingency table. Or using pandas crosstab, we can find the contingency table. What contingency table or the crosstab method will give you is the count of the two categories. The count of analysts being female is 2. The count of analysts being male is 4. That means there are 4 records belonging to analyst who's being male are 4 are present in the data set. So this is contingency table. We need to pass this contingency table as input to the chi2 contingency method, which actually calculates the p-value and all the other stuff. Okay, so let me execute this and show you. So when I executed, it actually calculated chi-square value and a p-value and degrees of freedom and the expected value table. So expected values are the contingency table of the data when null hypothesis is true, right? So how to calculate that, what exactly that table is going to be explained in the next session, but let us see the values here. So when I executed and looked at the expected table, right? The expected table, see this, we have got 3 rows here and 2 columns, 3 rows and 8 columns. So the first row belongs to F, the second row belongs to M, and third row is the total, R. In the same way, the first 7 columns belong to different designations in the organization, and the 8th column belongs to the total. So here the 32 is the total number of records. Even in the original observed values contingency table is also 32. So this is a observed values contingency table, and this is a expected values contingency table. We will use some probability theory and try to calculate this here, and I will show it in a moment. But before that, let us try to see what is the p-value here. The p-value is 0.98. That means it is more than, greater than 0.05. So we need to accept the null hypothesis. When the value is less than, the p-value is less than 0.05, we should reject the null hypothesis. Here the p-value is greater than 0.05. That means we need to accept the null hypothesis. That means the gender and the designation are independent. As business explains that gender cannot predict designation, the chi-square test is also showing the same thing. So now let us see how exactly the expected values are calculated and how exactly the chi-square test is being performed by a statistician. So let us go back to the slide and see that. So the chi-square test formula is that sigma I is equal to 1 to R and sigma I is equal to 1 to C, observed values minus expected values whole square divided by expected value. So this is the value, this is the chi-square value it calculated. If you look at this chi chi value, right? I did not print it. Let me print that. See that it is 5.36361. That's what it calculated. So this formula is being calculated by chi2 contingency method in SciPy stats module. So how is it calculating expected values? Let us see that. So this is the observed value table, right? In the data set, we have got 2 people who belong to, who are analysts and female, 4 people who are analysts and male, 0 people who are directors and female, and 2 people who are junior developers and female. Like that it is, the observed data. Now we need to calculate expected value. Right? The expected value is the probability of a gender having a designation when null hypothesis is true. Probability of a gender having a designation. That means probability of female being an analyst when null hypothesis is true. What is null hypothesis? Gender and designation are independent. When gender and designation are independent, we can calculate the probability or the expected value using below formula. Let us see this. Probability of gender is equal to G, a general number, and a designation D, a general character, for number of records belonging to G and D is equal to probability of gender is equal to G into probability of designation is equal to D. That means when the gender and designation are independent, you can calculate individual probability. You can multiply the individual probability and calculate the combined probability. We call this as combined probability, and then you can calculate that by multiplying the individual probabilities. Where the G has got M and F, 2 categories, and D has got director, junior developer, all the distinct values in the column. Okay, so let us see how exactly we calculated that. So probability of gender being male and designation being junior developer can be calculated with probability of gender male into probability of designation junior developer, because we are calculating the probability when null hypothesis is true. When null hypothesis is true, gender and designation are independent. You can multiply the individual probabilities and calculate the combined probability. So probability of male, how can you calculate that? How many male employees are there out of total number of employees? That means 14 by 18 by 32. How many male are there is 18 and total is 32. And the probability of junior developer, right? The probability of junior developer can be found by junior developer 2 are there out of 32. So it is 2 by 32. This is for one designation and one gender. If you want to calculate for all 32 records, you need to multiply this probability with 32. So that's what we did. 32 into 18 by 32 into 2 by 32. That actually is equal to 18 into 2 by 32. The value is 1.125. Like that, we calculated the expected values for all the combinations. Okay, here also we have got 32 as total, because the total number of people, and here it is count in the original values. Here it is probability, but even when it is probability, the total should equate. Total should be same. So after calculating expected values, we already have observed values. We can substitute the values into this formula. So when we substituted the values into the formula, we have got 5.361. Expected value, observed value 2 minus expected value 2.625 whole square divided by expected value, plus observed value 0, expected value 0.875 divides whole square divided by 0.875. Like that, we multiplied and did squares and summed it up. We have got 5.361. If you look at the same in the code also, you see the chi value is 5.36155. If you round it off, it becomes 5.362. So that's how the chi-square test calculates the chi-square statistic. But to decide whether to reject the null hypothesis or accept a null hypothesis, we need to understand the degrees of freedom. Generally, the degrees of freedom is if you are using only one column, and if the column has n number of values, n minus 1 is the degrees of freedom. Or if you are looking at only one row and you want to calculate degrees of freedom, if the row has got m number of values, it is m minus 1 is the degrees of freedom. Okay. So in a contingency table like this, right, the degrees of freedom formula changes. So r minus 1 into c minus 1, number of rows minus 1 into number of columns minus 1. Here we have got 7 columns and 2 rows. So I calculated and I have got 6 as the degrees of freedom. In general, when you talk about degrees of freedom, when how many values are missing in the data set, you can find it. That's the degrees of freedom. If you have one column and you have total of it, even if you miss one value, you can find it, because a plus b plus c is equal to the total. If b is missing, you can find b is equal to total minus a minus c, right? That is degrees of freedom. That's what we explained. In a column, it is n minus 1, or in a row, it is n minus 1. But if it is a contingency table like this, right, it's going to be r minus 1 into c minus 1, that is 6. So we need the statistic and the degrees of freedom. Using these two, we can actually find out whether the null hypothesis should be accepted or rejected. Let us see that. To do that, we need to actually look into the table of chi-square statistics. In that, we'll have the significance level 0.05. For the degrees of freedom, a value will be there. This is called as critical value. Your chi-square statistics value is, if it is less than the critical value, we need to accept the null hypothesis. If it is more than the critical value, then we need to reject. We can reject the null hypothesis. The critical value is 12.59. The chi-square statistic is 5.361, which is less than the critical value at the 6 degrees of freedom for the significance level, 5% significance level. So we need to accept the null hypothesis, and gender and designation are independent. This is how a statistician calculates. And in our code, right, we have the method, right, chi-square contingency method, which actually takes the contingency table and calculates the expected values, and it applies the chi-square formula and calculates the p-value and chi-square value and all that, right? We just need to understand the concept. The methods are already there. The question I try to answer here is that the chi2 contingency method needs a chi-square table, contingency table, because to calculate the expected values, you need contingency table. We have seen that example here. Using the values inside the observed contingency table, we are calculating the probabilities of the expected contingency table. This whole calculation is done by the chi2 contingency method. So that is actually how you do a chi-square test using SciPy's stats models, chi2 contingency method, and how exactly the math is happening also we have seen. And in the next session, we will actually understand when the input feature, there are 2 categorical columns, and the input feature has got more than 2 categories, how to do contingency test. We will understand that. Thank you.